Welcome to sports betting systems with Akka. Yes, Akka. Before I start, does anyone know who this gentleman is? Brad, shout it out. Johan Cruyff. One of, if not the best players of the game ever. Certainly one of the best, if not the best manager ever. Totally changed football. So if you ever want to learn more, look up Total Football. Ajax, Barcelona, Dutch national legend. Obligatory introduction. I'm Trevor Burton-McCreadie. You'll find me all over the internet, some form of think more, stupid less. Often think more stupid, depending on how I'm feeling on the day. I work for Lunatech. We are around about 120 people from 30 or 40 different countries. Offices in Amsterdam, Rotterdam, Paris, and Brussels. And we're really good. You should hire us. But this is not about Lunatech. This presentation is all about me and my personal exploration of sports betting, or a small fraction of it. I was introduced to sports betting by an uncle of mine. When I was too young to legally go into betting shops, he'd take me in, showed me how to bet, and going into this magical, illegal world of betting for a 13, 14-year-old kind of completely got me hooked. When I moved to university in London, I got a job working in a betting shop and found that actually the reality is very different. These are desolate, horrible places full of despair, punctuated by the very odd moment of brightness when someone has a rare win. You'd see people going to pick up their employment benefit check from the post office, come 2 doors down to us, and then spend most of that money immediately because they're just compulsive gamblers. Ruins lives, and the bookmakers must be stopped. So I'm going to show you a little bit about how to do that. One of my colleagues called the shop the most divorced place on earth, and that was pretty accurate. Oh, yeah, so one of our values at Lunatech is humility. So I'm going to start this presentation with a biblical reference. Bookmaking, betting generally, is all about this battle. It's a cheetah versus gazelle arms race between the price makers and price takers. The price makers for a long time have been the bookmakers. And I usually have a section, bit of a background about how bookmaking works, over rounds and making up a book and balancing things. But with a shorter time limit, I've cut a lot of that out. But I think it's important to give you a bit of an understanding about prices and odds. So here's an example of a market or a match from a couple of weeks ago. United Emirates versus Bangladesh, Clash of the Titans. I've chosen popular cricket because it's such a beautiful contradiction in terms. But the prices here are exactly the same, right? They're just different formats. There's decimal odds and there's fractional odds, and they mean exactly the same thing. They mean two things, actually. They are the implied probability of something happening, and they are also the money you will win if your bet wins. How do we calculate the implied probability? Well, it's a simple inverse relationship. The higher the probability, the lower the price. The lower the probability, the higher the price. So if we look at decimal 5, it's the same as 4 to 1. If I bet £1 or 1 shilling or 1 shekel, I will get 5 back. I'll get my original 1 plus 4 in profit. So the fractional odds kind of show us that. I bet 1, I get 4. 1.17 is roughly equivalent to 1 to 6. It's better than evens. We refer to it as odds on. If I bet 6, I get 1 back. So it's not a great deal because it's very, very likely to happen. We add up the implied probabilities. We get more than 100%. Why do we get more than 100%? Because that's the bookmaker's profit. This is what's called the overround. And if the bookmaker balances his book correctly, then he'll make 5.5% of all the stakes, no matter what happens. So the bookmaker always wins, unless they're stupid, in which case they go out of business pretty quickly. And they can also, right, so this is an example of the different types of bookmaker. There are soft bookmakers and there are sharp bookmakers. Sharp bookmakers review their odds almost second by second. They are very up to date. They have low margins and they will take big bets. Pinnacle are a really good example. A company called Pinnacle, you can go to put 50 grand on a match on the nose with Pinnacle, no problem. Popular games, you'll get even more on. Above that, you have to go to the Asian syndicates, and it's really frightening. Soft bookmakers won't take as much money. This is an example from a couple of weeks ago, me trying to get 200 quid on Bristol City to get promoted to the Premiership. They won't risk a payout of £3,400, so they limit me. So this is one of the ways in which bookmakers will balance their books. What's next? Yeah, so up until around 2000, the bookmaker was the only way to get money on. They were the price makers. Around about 2000, just after, we got into really good liquidity at Betfair. Betfair is an exchange, and Betfair does something slightly different. Betfair allows you to be the price maker as well. So if, Brad, if you're a fan of the Cherries, you're going to get money on Bournemouth, or you're going to back Bournemouth to happen, to win. I will lay Bournemouth. I don't think Bournemouth are going to win. I think it's going to be a draw or West Ham will win, so I lay that bet. So it's the equivalent of shorting in the financial markets. Yeah, you're betting against. And this is kind of revolutionary, and it's great business for Betfair because whatever happens, they take 2% of the winnings. So they are rolling in cash. And yeah, they do really well out of this. So that's just another close-up of that. So how do we beat the bookmakers? How can we do this? There's two ways. Well, there's actually three. First of all, we can know more than the price maker. So we have some information about the game, that we know something's going to happen, and it means that our estimation of the true probability is better than theirs, and our estimation of the true probability says it's more likely to happen, and so the bookmakers' odds are higher, so we've got what's called a value bet. There's value in this for us, so we can put money on there. You are not likely to get a value bet on the NFL from Vegas lines. You are not likely to get money on a value bet from, on the Premiership at William Hill. The famous big kind of events and tournaments and competitions are really well modeled. You will find an edge on the Dutch women's second division. You will find an edge, at the moment, on esports. If you know and do your homework about the Dota 2 teams or CSGO teams, there are really badly modeled markets at the moment here and there that you can pick up on and you can make money. So there's value betting there. There's something called match betting as well, where you can take advantage of the offers that bookmakers make. But they're likely to get you banned because they recognize that you're only betting on free bets and things. The other, which we'll explore in the rest of this presentation, is about exploiting price movements. In this case, we don't care what we're betting on. We don't care what sport, we don't care about anything. We just care about these streams of numbers that are coming in. So you can see where I'm going with Akka, right? We've got streams of numbers coming in and we want to compare things and find an advantage that way. The secret special, the option 3 here, is that you can do a little bit of both. Tennis is a good example. If you've got the number 1 seed playing the number 40 seed, every now and again, maybe he's got a cold coming on, or he's had an argument with somebody, and he'll drop the first set, or she will drop the first set. And their price will move way out from like 1.4, we've seen them go beyond 3, and you can back them there, and they come back. They're the number 1 seed, they come back and they storm the rest of the sets and they win the match, but we've got value at 3. So there's a way in certain events on certain games that you can do both. But we're going to focus on that second part, and a specific way of doing this called arbitrage, which you may be familiar with. Let me run through very quickly. Traditional arbitrage, what we're doing is making a book from multiple bookmakers. So we've got different prices here from Bet365 and Pinnacle, and if we put a £500 total stake or $500 total stake, what we'll end up with is a guaranteed $6.09 win. Whatever happens, or 6.10 if we're lucky. That extra cent matters, right? What's happening is we've got 21% probability on here and a 77% probability on here, which adds up to 98. That's less than 100. This is an under round. This is a 98% book, means it's value for us. An over round, greater than 100%, is better for the bookmaker. So if we can create our own book with an under round, we can make some money out of this and we can lock it in. So this is the essence of it. I'm going to show you a slightly different way to do this, a hedging version. where we can use Betfair's lay capability rather. So if we've got a price of 3 on Federer at Pinnacle, and we can lay at 2 on Betfair, and we put 100 quid on at 3, we get 300 quid back. We get £200 plus our stake of 100. The important mathematical thing here is we take the return, we divide it by the odds of the back, and then we use that as the liability on our lay bet. That's it. That's the trick. And then we can guarantee, we can lock in. Whatever happens here, we make 50 quid. This is called a £50 green, or a £50 green book, or a green bet. The green meaning profit as opposed to red meaning deficit. A £50 green is like a white hole in cosmology, right? Theoretically possible, but never really observed in the wild. Realistically, £5, £6, dollars, you're doing really well. So this is an incremental kind of thing, right? And if we make any kind of mistake, we've lost £100. So if we're, even in this example, we've got to make 2 successes to make up that failure. In reality, you have to make hundreds of winning bets to make up for 1 failure. So again, you can see where I'm going with this with Akka and Reactive and handling failure, right? So it's a really good use case for this. So the process is we place the lay bet on Betfair first because there's a way to back out of that position on Betfair. We can back. So if our lay bet fails, we can go place a back bet and we can get out of that position. If we're lucky, we get matched, then we just zero out and we've not lost anything. If the lay bet's successful, then we place the back bet on Pinnacle. And an important point is that we can do this automatically, right? We have APIs for this. The softer bookmakers won't have APIs for obvious reasons, right? They don't want people exploiting this stuff. There's ways around that, and if you pay me thousands of pounds, I will do it for you and explain, but not on here. And if we fail on Pinnacle, we haven't put the money on, but we've still got the lay bet, so again, we go back and back. And then if we're successful, then ka-ching. So what we want to do is take the stream of Pinnacle prices, the stream of Betfair prices, check to see if there's an arbitrage opportunity, and if so, give it to an actor and let it play out this scenario, this model. So, here's just another example of what I'm doing here. We need to know how to connect one thing to the other, right? When we get a Betfair price, we need to be able to connect it to a Pinnacle price. So we need to match the markets. And this is kind of an important thing that I'm leaving out here. Matching markets is one of the hardest things to do in this game. It's one of these things where it's really easy for a human to do, to see that it's Manchester United here and it's Man U there. But getting a computer to do this reliably is something that's eluded me so far, and others too, because, again, we cannot fail. If we get Man U and we get some other team, then we can find an arbitrage opportunity that doesn't actually exist and waste our money and send it to nowhere. So, and give it to the bookmakers who are evil, who we want to defeat. So we need to be really careful. So it's usually a manual process, but you only have to do it once. Then you've got that registered, and you can match a Betfair ID to a Pinnacle ID, get the latest Betfair prices when you get the latest Pinnacle price, and then do the arbitrage thing. And if it's successful, give it to the actor. So in code, so I spent some time this week working this up, a really kind of naive, trivial kind of example. But this is what it looks like. So I'm assuming everyone can see this. So we'll start our actor in this waiting state. And in the waiting state, all it can do, the only message it can receive is this new opportunity message, which contains the info, the arbitrage info, the opportunity. It's somewhere there. Yeah, there it is. So it's just this arbitrage info, which is the selection and the price for Betfair, the selection for price for Pinnacle. So it's just like a wrapped up version of this. So, where are we at? Once we've received that message, we'll start the process with triggering the lay bet. And I've just mocked this service up to, sometimes it will succeed, sometimes it will fail. So we can just mimic this and we can see what it looks like. And then we move into this working state. So we can use the actor's ability to model, to be a state machine, basically. Now it moves into this working state. If we get the lay bet failure, then we back on Betfair. If we get the Betfair lay success, then we back on Pinnacle, right? So it's the same model, and it's just played out on here. And I've added some custom metrics here so we can see some nice graphing. So that's the actor, right? That's relatively straightforward. There's a lot of typing, but it's relatively straightforward, and we can see from our message handling exactly how that works. Now, the trickier bit, and Scala format has screwed up my really nice little diagram there of how this looks, but essentially, we've got a repository which contains the ID matches, a repository which contains our latest prices typed, keyed by an ID, and I've used the Akka HTTP cache here, which, so this is a Akka HTTP cache. It's just a nice way of getting stuff in and being able to do things. Just a kind of cheap shortcut. We can back that by a database as well. I just didn't have time to do that. And then we have our sources. So this is our Betfair market source. So we get the events from Betfair, the prices from Betfair. And Betfair have a really nice stream-based API socket that you can connect to, and you can tell it, I want to subscribe to these markets, and it will send you the changes. It will push them to you. Pinnacle, you have to poll, so you can make that into a stream yourself, but it's relatively trivial to do. Betfair API, I have to say, is just one of the wonders of the modern world. Absolutely fantastic. I don't know about message-driven, but all the reactive principles are in play there. I've used it for thousands of times a day for years, and I've never seen a single bet fail. It's like unearthly. It's brilliant. So fair play to them. So we can create this source, and then we can map getting the market book, registering the market book. So this is our latest Betfair prices stored in the cache. Then we can pull the Pinnacle ID. I've used cat's option T here to just save some complicated for stuff. And then we can get the market book for that ID. And so what we're returning is this tuple of Betfair and Pinnacle market books. Same thing, just the inverse for Pinnacle. So now I've got two sources, my Betfair source and my Pinnacle source, but they are both a tuple of Betfair and Pinnacle. So I can merge them, right? I can merge them together and then push them through this decider, right? The decider checks if there's arbitrage opportunities here. And it does this with this cool thing here. This is my percent difference operator. I may not have used the mathematically correct symbols, but I don't care. It's my code, and I'll do it how I like. So this is the maths here for checking the difference. It's relatively straightforward again. Subtract 1, divide the rest, off you go. And then, once we've merged all that in together, we name it here because I'm going to show you this running in on a graph, and we've used Cinnamon for that. But this is the important bit. If we have an arbitrage opportunity, then it will push it to this arbitrage actor, right? So it will spawn a new actor, and then ask it the process opportunity. It'll send it, and then it will need a response so that it can back pressure the rest of the flow. So the speed at which we can spawn actors and get these things moving, that will back pressure all the way back. When I run this, you'll see we're going to get a lot of arbitrage opportunities. In reality, again, this is not something you see. You'll get, I don't know, on a Saturday with all the Premier League games going, you might get a handful, right? It's not a high volume game, but it works and it's guaranteed money. So, you know, there's that. So let's run this. If I can find the right thing. This is where things always fail. So what could possibly go wrong with a live demo? Oh, no, it's running. Right, that's stage 1 done. So now I can see it's hammering through these opportunities. And if we refresh this, or we wait for this to refresh, in a moment, I sweat for a few seconds and talk to stretch it out. Oh, no, look, we've got a graph. So we can see we're starting to get things moving through. And if you're using Akka and you're not using Cinnamon or Akka Insights or whatever Lightbend are calling it this month, then you'll find, then you need to have a word of yourself, really, because it's absolutely fantastic. Yes, you can use Command and it's open source and whatnot, but for Akka Streams especially, the level of insight and being able to sample things so you're not really treading on performance, there's just nothing else out there like it. It's really good. And so if we go into the Akka Streams, and these are all just the default things apart from that, that custom dashboard, we can see we're getting running streams. We can see the throughput here. We're getting 14-something thousand operations a second. This Mac it's not a bad Mac, but the fan's just coming on. So we can get a lot of these things through. And this is just a single Akka application. 6 hours, come on. So can we fix that? So it remembers. So we've got, yeah, 500,000, more than 500,000 opportunities being handled here. So, you know, responsiveness is not a problem. So let's look at resilience and have a think about that, because we want to be reactive. So I've added this little section in here, this supervision strategy. At the moment, there's no supervision on this. So if it was to fail, if one of these actors fails for some reason, then it's going to kill the whole stream, and it's just going to stop processing things, which might not be a bad thing, right? We want the whole thing to shut down because we don't want to lose money, but we also don't want to miss an arbitrage opportunity unnecessarily. So if we go back to the actor here, we can say, Pinnacle backpacks. Yeah, so if we stop the actor at this stage, say, stopped, yeah, if I can spell correctly. So if we stop the actor there and run this again, yeah, so it's going to kill it. It's going to die now because the actor failed. This message wasn't handled correctly because it's trying to send something to an actor that stopped, and everything falls apart. So we can handle that with our supervision here. So if in this map async stage, we can do these things. So you can supervise the whole thing. You can supervise particular stages. Akka Streams works really nicely for this, being able to handle failure at particular parts of the stream. I suppose I should really prove that that actually works, just for completeness. Okay, ignore that. Let's move on. That was a last-minute addition. It's not my fault. It does work. So what have we got left? 7 minutes. Right, I'm going to jump through the next section because what I was going to say was the next section kind of introduces this problem that we have with that particular thing, which is these arbitrage opportunities are going to last like a second, maybe two at the absolute most. So we need to jump on them and we need to do something really quickly. But what can happen is we can place the lay bet and then Pinnacle can change their price. Or we could place the lay bet and then place the Pinnacle bet, but something can change, right, in the meantime. So we want to be able to catch that, because otherwise we're going to place the lay bet, place the Pinnacle bet, which may get placed because Pinnacle will allow us to get the bet placed when the prices have moved in our favor. But then we're going to not have an arbitrage opportunity anymore. So we can lose money if the wrong side wins. And Sod's law says that the wrong side will always win and we'll end up losing. We never get lucky. I ran this for nearly a year and not once did I get lucky with that. So, you know, just you need to cover your back. So what we can do is change the process so we can have two flows. And instead of trying to join things in the stream, we can push the state where the logic is and put everything into the actor. And we can feed the actor with a stream of Betfair prices and a stream of Pinnacle prices and let the actor decide, right? So it can, while it's processing the lay, it can receive updates on Pinnacle. If now it's not an arbitrage opportunity anymore, it can go back and back out the Betfair position. So we can add more compensating actions if the information it needs for the logic lives next to the logic. How do we connect those two things? The receptionist is a good example of doing this. I'm not going to run this example because I'm running out of time, but we can have, oh, sorry, I've got my reading glasses on. Is that 5 minutes? Thank you. So we can, we can run the same stream. So we don't merge the streams now. We have two streams of Betfair, a stream of Betfair, stream of Pinnacle, and then we can send them to this arbitrageur actor, right? But how do we find the arbitrageur actor? We ask the receptionist, and we can key it by the market ID of the market, our universal ID that we've created that will map to both the Pinnacle and the Betfair market, and then that will give us a unique actor for that particular selection on that particular market. So for all the thousands of markets and the many selections that we're trying to arbitrage against, so we can have an individual actor for each one, and then just feed the data into that. The receptionist API is fairly straightforward as well. We can just ask it for the listing for this key, and we get back the list of all actors, because you can register more than one actor for a particular key. So here we can just pull the head and fold over it. If it exists, return it. If it doesn't, create one, register it, and return it. Or the registration is done in the arbitrageur itself. Always go the wrong way. Yeah, so we can just call the receptionist and register ourselves when that actor's created. Again, I'm running out of time, so I'm not going to show that example. The third example I wanted to show is, this is just running on one machine. So if that machine fails, we're losing opportunities again. So let's embrace Akka and go for it, right? And run this on a cluster. So I'm not just going to run it on the cluster, because that would be too easy. We're going to go mad, right? I'm going to get the services running in a cluster singleton, because I only want to connect to Betfair once. So it makes sense to have a cluster singleton. I only want to connect to Pinnacle once, cluster singleton for that. I've merged the two for simulation purposes. And then I want to distribute the processing. So, okay, thanks. So we're going to have multiple fixed number of processors. And those fixed number of processors are going to send a sync ref to the cluster singleton, and that singleton is then going to connect those syncs and shard the markets across them. And then we shard the arbitrageurs across the cluster as well. So now whatever happens if a node goes down, Akka's going to rebalance everything for us. A new sharded daemon process comes up, registers a sync ref, and starts picking up the messages from that shard. So sync refs, really short in time, but sync refs are really, really useful when you want to send things across the network. Absolutely brilliant. And basically, all you have to do is send that ref, and you'll get the messages sent down. So in this case, we're merging everything into a merge hub, and then we're just broadcasting everything to the available syncs after doing our shard algorithm. The last step I wanted to talk about was then introducing Kafka. So for this, and I've put this code up online, so go to Think More Stupid Less on GitHub, and you will find all this code. But we can use Cloudflow, which is a criminally underused piece of technology, which allows us to create Akka Streams applications and wire them to and from Kafka really nicely. And it also gives us a nice configuration file which tells us how things are connected up as well, because the Akka Streams code can get horribly messy and spread out everywhere, and you can't really tell what the flow is. Cloudflow goes some way towards solving that problem. So we can create the two streams, put them onto two different Kafka topics, and pull them, and still have an arbitrage cluster, still have a cluster within Cloudflow as well. That was Nolan's invention over there, yeah. Well done. So you can create an Akka cluster and then scale that as you scale pods in Kubernetes. Last thing is running the application. Don't use Kubernetes. Don't go on the cloud. It's too expensive. You're not going to make a huge amount of money from this, so save your money. And if you've got some old Raspberry Pis knocking around, go to Eric Lutz's thing, another Lunatech, an ex-Lightbend employee, created this way of running Akka stuff, Akka clusters on a Pi cluster, and you can save yourself a lot of money and feel like a real technology engineer with like lights and stuff. It's brilliant. It's fun. And look at this, I'm bang on time to say thank you very much. Any questions? Sorry. Oh, come on, it's one question. Why am I doing this? Pardon? If you give me £1 million, I'll tell you. Go on, Nolan. Yeah. It's already done before it gets to the merge. I'm taking the market book for Manchester United, so the home team, the away team, and a draw, and then flat mapping that. So we've got just 3 streams, and it's already connected before it gets to the merge. So we've got a tuple. We've got the Betfair selection and price, the Pinnacle selection and price that matches, and that travels along and gets merged and gets sent along. So it's not, they're already paired before we get to the merge. But you could do it differently. This is just my, like, naive. Too late. Thank you for a question. Cheers. Oh, 2 questions, sorry.